Welcome to another lesson in integral calculus. So this is a continuation of my last lesson, which was about getting the integral of sine and cosine functions. Those functions are raised to an integer exponent. Okay, we began with 2 as the exponent. And what we did last time is we used the power reduction formula. So from a degree 2 sine function, we were able to produce an equivalent function which is a degree 1 function. Okay, so this is a continuation of that part. So what I'm trying to emphasize here is when we are integrating trigonometric functions, it helps a lot to know your fundamental trigonometric identities. For example, find the integral of the square of tangent of x over 2. The integral of the tangent function is not, or the square of the tangent function, that is not among the basic forms of integrals that I showed you last time. So what we shall do is we will replace tangent of function by this, okay? Going back to your trigonometric identities, 1 plus tangent, the square of tangent of x is equal to the square of secant of x. And so from this means that the square of tangent of x can be written as the square of secant of x minus 1. And this one is listed among your fundamental basic forms for the integral. So coming from the square of tangent of x over 2, we replace it with this, the square of secant of x over 2 minus 1. And then we will get the integral of this function, okay? The integral of the square of secant of x over 2, that is equal to 1 over 1/2. So that is 2, and then tangent of x plus c. And so in this case, the integral of this is going to be 2, 1 over 1/2 times tangent of x over 2 minus the integral of 1 dx is simply x. Okay? This again is another example wherein your trigonometric identities will be helpful. Okay, so right away when you look at it, wow, it's kind of intimidating. But it turns out that we can take advantage of your fundamental identities. The square of cotangent of x is just equal to this, the square of cosine of x divided by the square of sine of x. The square of sine of x divided by the square of sine of x, that is equal to 1. And so we are left with this, the integral of the square of cosine of x. Now this is where your power reduction formula will come in. You will replace this by this. And this now is easy to integrate, okay? This is equal to, so we can write it this way. The integral of 1/2 plus 1/2 times cosine of 2x dx. And you know this to be equal to 1/2 x plus 1/2 times 1/2. Okay, this the reciprocal of the coefficient, that is 1/4. And the integral of, or the antiderivative of your cosine is, of course, your sine function. Okay, another example. This is where your trigonometric identities will be helpful again. This one is not listed among our basic forms for integration. What we have is the square. What we have is something for the square of cosecant of x. What we have is, among your basic forms, is the integral of cosecant, the square of cosecant of x dx, and this is equal to negative cotangent no, negative cotangent of x. Negative cotangent of x plus c. So we will replace, excuse me, I will go back. So we will replace this by the square of cotangent of 1 half x dx is equal to the square of cosecant of 1 half times x minus 1 dx. This is equal to the reciprocal of 1 half, which is 2, and the antiderivative of the square of cosecant of x is negative cotangent of x. So that's going to be negative 2 cotangent of 1 half x minus x plus c. So last time we spoke about how to integrate sine, the integral of the square of sine of x dx, and the integral of cosine, the square of cosine of x dx. But now, what we have here is sine or cosine raised to a positive odd integer. So what will you do when you meet something like this? When you see something like this, sine, cosine functions, but the exponent is an odd exponent. So what we're going to do here is this. We will factor out one sine or one cosine. After factoring out, we will use the identity, this identity. Okay, the square of sine of x plus the square of cosine of x is just equal to 1. And then along the way, we will use the substitution method. You will know what I mean when I show to you how to do this. Get the integral of cosine of x raised to 5 dx. Again, we factor out one cosine. Look at that. We factor out one cosine, so it becomes cosine of x raised to 4 times cosine of x. Now you know that cosine of x raised to 4, that is just equal to the square of cosine of x and all of that squared. Okay? And your Pythagorean identity will come in here. You will replace this by 1 minus the square of sine of x. Okay? So again, cosine of x raised to 4, that is the same as this one. The square of cosine of x and all of that squared. You replace this by this. What do you do next? Well, look at this. You will expand this. Okay? A minus b squared is equal to a squared minus 2ab plus b squared. Okay, so this is the result. And then you can separate this into 3 terms, okay? Sine of x raised to 4 and then times cosine of x dx. So you will integrate this term by term. Now I know that there is a lot of things to do. There is a lot of intermediate steps to do. Is there a way that I can shorten it? There is no way. This is the way. So what is the integral of, this one, what is the integral of cosine of x dx? Well, the antiderivative is just sine of x, okay? And then, look at this, the minus, and then look at this one. We will get the integral of 2x, that's x, and then cosine of x dx. What shall we do with this? We will do substitution. Let u be equal to sine of x, du is cosine of x dx. So this one will become the integral of 2u squared, okay? U is sine. So the square of sine is the square of u. And then this one is just du. How do you get the antiderivative of this? Well, you apply your power rule. So this one is equal to u cubed all over 3 plus c minus 2 over 3 times u cube, which is the cube of sine of x. And you will do the same for this. The integral of sine of x raised to 4 cosine of x dx. Again, substitution, let u be equal to sine of x. So du is just cosine of x dx. So this whole thing is just the integral of u to the fourth times du. This one is just du. And this is equal to u to the fifth power all over 5 plus c. Okay? So this is the result. Okay? This is the result. Okay, so let us go back to what we did. So we have this function, the integral of cosine of x raised to 5 dx. We factored out one cosine. That is what we did here. And then we wrote this, the fourth of cosine of x, we wrote it as, this is the square of cosine of x. This one came from your Pythagorean identities. This is the square of cosine of x. Then all of that squared, that's equal to that. And then after that is we will apply the linear property of your integral. Okay? We will integrate this term by term. And then along the way, we discover that we shall need your substitution method to get the antiderivative. I know that that is a lot of things to do. I know. I don't know how to shorten it. I don't know. Unless, of course, you memorize this integral, which is why, by the way, in many textbooks in integral calculus, at the back pages of the front and back page, you will have there a list of integrals. Well, if you can manage to remember all of them, well, maybe that is the only way to shorten the steps. Let us get the integral of sine of x raised to 7 dx. Again, factor out one sine. It becomes something like this. Okay? Now this one, the sine of x raised to 6 power, that is just the same as the square of sine of x, all of that raised to 3. Okay? And then we will use your Pythagorean formula to replace the square of sine of x. And that is equal to this, 1 minus the square of cosine of x, all of that raised to 3. And then what do you do after this? Well, you will go back to your expansion, the expansion of a binomial, okay? A plus or a minus b. The cube of a minus b is equal to a cube minus 3a squared b plus 3ab squared minus b cubed. And that is what we did here. That is what we did here. When we expand this, if you don't remember the special product, okay, for a plus b raised to 3, if you don't know the special product, well, you just have to do this manually. First, you will get 1 minus the square of cosine of x squared, and then multiply it to 1 minus cosine of x squared again. Okay? And this is the result. Okay? Expanding this will give you this. And then all of that times sine of x dx. And you will integrate this term by term. And along the way, you will do the substitution method again. Let u be equal to cosine of x du. Du is sine of x dx. Yeah. Is there a way I can find an easier route, a shortcut? No. I don't know of any shortcut. Even I don't memorize all the integral formula in your textbooks. And this is the result, okay? The integral of 1 sine of x dx is negative cosine of x. Here, you will apply the substitution method. Let u be equal to cosine of x. Du is sine of x dx. So the integral of this is u cubed all over 3. But u is cosine. Here, the integral is u to the 5th all over 5. But u is cosine. Minus the integral of this, u raised to 7 all over 7, but u is cosine of x. Now, how about when n is a positive even integer? We already met this, but the integer exponent is just 2. What if the exponent is 4 or 6 or 8? Okay, so this is what you do. Okay, again, we will take advantage of your power reduction formula. So you know what's going to happen here. This will be replaced by your power reduction formula. Okay? So for example, find the integral of sine of x raised to 4 dx. So we will write our sine function not as sine raised to 4, but the square of sine of x, all of that raised to 2 dx. And then we will replace this by your power reduction formula. This is equal to 1/2, okay, 1 plus cosine of 2x. And then all of that, okay, all of that is squared dx. Okay. So it should be 1 minus, okay? I don't know what I wrote there. It should be 1 minus cosine of 2x. Okay, so all of that raised to 2. And so that 1/2 there raised to 2 becomes 1/4. What do you do next? Again, you apply your special product for a minus b squared. It is equal to a squared minus 2ab plus b squared. So we will bring out 1/4. This, after applying your special product, is equal to this. Now, it's easy now to get the integral of 1 dx. That's just x. And so with this one is just equal to minus 2 times 1/2 sine of 2x. So 2 gets cancelled, and that is what we have, minus sine of 2x. And then we will do this, the integral of the square of cosine of 2x. So this is where your power reduction formula will come in. So you will write this as, okay, the integral of, so this angle is going to be doubled. So the integral of 1/2 times 1 plus cosine of 4x, okay, dx. And this is equal to, okay, the integral of 1/2 dx is 1/2 x. The integral of this is equal to, that's equal to 1/2, okay, this 1/2 times 1/4, okay, and then the antiderivative of cosine is sine. So 1/2 times 1/4 is 1/8, okay, but this one is just for this. Okay, so putting them all together will give you this result. The integral of sine of x raised to 4 dx is equal to this. Right now, I'm thinking about how am I going to prepare an exam for this? How am I going to prepare a quiz for this topic? I honestly don't know for now. Okay, so in my book, I uploaded the PDF files of the sections of my book. I posted there some exercises with the answers, solve problems. So this is what you can do. You try getting the antiderivative of the cube of sine of x dx. And this is the result. This must be your answer, okay? The same with the integral of cosine of x raised to 3. This is supposed to be the answer. So this one will be a good practice for you. I know that this lesson contains a lot of information. The techniques contains a lot of intermediate steps. And that is why integral calculus is just about laying down the techniques. Okay, for much of our course, for much of our lesson here for the first semester, all we shall talk about are the techniques to get the integral.